Hello and welcome to today's math lesson. So first of all guys, can we all turn to wave and say a big hello to our friends on camera? Hello. Hello. And we'll begin by doing our meditation sequence. So I will sit down, take 2 fingers, find our heart center, left hand on our laps and close our eyes. And when you're ready, guys, you can open your eyes and come back to the room. And next we'll do our stretch sequence. So let's stand up and push in our chairs. Let's begin by stretching up high to the sky. High as we can. And then let's go down low. Touch our toes. Back up high one more time. This time, can we go tippy toe high? While we're there, let's have a wave side to side. And then back down to touch our toes. And then hands on hips. And let's have a wiggle side to side. Stop. Another wiggle side to side. Stop. Forwards, backwards, forwards, backwards, forwards, backwards, and stop. And then we'll go round and round. Give our spines a nice stretch, round and round. And then back the other way. Round and round the other way. And stop. And to finish, we will do 5 claps. 1, 2, 3, 4, 5. Excellent, guys. Have a seat. So who can remember in our previous math lesson, we began learning about a particular type of fractions. And it's quite a hard word to say, so we'll say it together. Ready, guys? Equivalent. Yes, equivalent. So let's write this phrase on the board. E, Q, U, I, V, A, L, E, N, T. Equivalent. And we're working with fractions. F, R, A, C, T, I, O, N, S. So all together, guys, equivalent fractions. Yes. Now, can anybody remember what we mean by the word equivalent? Same amount. Yes, that's very good. Equivalent means the same amount. Sometimes we might have different fractions, but they're the same amount. And that's what we call equivalent. So, we'll write that word on the board too. Same, M-E, amount. Excellent. And what we're going to do now, as a recap of the previous lesson, is I will write a fraction on the board. And then I will ask a student to come forward and draw an equivalent fraction, which demonstrates their understanding of how the different fractions can represent the same amount. So first of all, we start off with a small simple fraction. Okay, how many parts do we have here, guys? 2. Now, how about if I colour in 1/2 of our fraction? Not 2 over 1, 1/2. Or 1/2. Yes, you can see now. But what I'm going to do, I'm going to ask my students to close their eyes. And when I give the pen to one of them, they will demonstrate their understanding by writing and drawing an equivalent fraction on the board. So let's see who can go first. Okay, so now the pen is with Nadia. So Nadia, come and join me at the front of class, please. So we have one fraction on the board, 1/2, or 1/2. And Nadia will now demonstrate how to draw an equivalent fraction. So Nadia, can we have a circle? Perfect. And now, this time, let's cut the circle into 4. Okay, so we can write our denominator 4. Now guys, looking at our circle here, how many parts of this circle? 2. Correct. So Nadia can colour in 2 parts of the circle and then write the numerator here. So you see how both fractions represent the same amount. This is equivalent. 1/2, 2/4. Equivalent fractions. Nadia, can you say equivalent fractions? Perfect. High five and a big round of applause for Nadia, please, guys. Let's do another one to show how our students understand further. Okay, how many parts to our circle now? 8. So that's our denominator. And how about if I colour in 4 parts? Okay, so now we've got a fraction 4/8. And now I'll ask my student to demonstrate how to do another equivalent fraction. And now the pen is with Chu. So Chu, come and join me at the front of class, please. And Chu will demonstrate how to draw an equivalent fraction. So what we've got here is 4/8. And what we need to do now, Chu, another circle. So you can draw another circle. Perfect. Now this time, let's cut our circle into 4. So we can have 4 different parts. And then another line going across to you. Excellent. So how many parts to our circle now, guys? 4. So we can write 4 as our denominator. Brilliant, Stu. Well done. Now, looking at our circle here, 4 over 8. How many parts of this circle need to be blue? 2, correct. So, Stu, we can have 2 of this circle in blue. Then we can write 2 and then your divider. Excellent. You see? Same amount, but with different fractions. And that's what we mean by equivalent. So altogether, 4 over 8 or 2 over 4 are equivalent fractions. Yes. Stu, can you say? Equivalent fractions. Excellent. Very well done, Stu. High five and a big round of applause for Stu, guys. Let's do one more together before we move on to the next stage of equivalent fractions. This time we'll go with a large number. So let's see, how many parts do we have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Okay. Eight. So we've got 16 parts. 8 over 16, you see? 16 parts, but 8 colours in blue. So let's do one more equivalent fraction of 8 over 16. And this time, the pen is with Lacau. So Lacau, come and join me at the front of class. So the first thing we need is a circle. Okay, guys, so this time, how many parts shall we cut our circle into? 4. Okay, we'll do it into 4. 1, 2, 3, 4. So we can have our denominator 4. So, looking at our circle here, 8 over 16, how many parts of 4? 2. Yes. And then write 2. Because we know 8 is half of 16. 2 is half of 4. So these are equivalents. So one more time, guys. 8 over 16 and 2 over 4, equivalent fractions. Lacau, that was brilliant. High five. Big round of applause for Lacau, guys. So what we're going to do in today's lesson is we're going to stay with equivalent fractions. But if you notice, the equivalent fractions we've been doing so far has always been half. But equivalent fractions don't need to be half all the time. They can be other amounts too. What we're going to do today is look at how we can do equivalent fractions based on quarters. So what we've got now is a PowerPoint presentation for our students to observe, listen to and practice speaking about some more equivalent fractions. So let's turn to look at the TV screen, guys. So let's take a look at our PowerPoint presentation, Equivalent Fractions, Lesson 2. Yes, and as you can see here on the front cover, like last time, we've got all different amounts of fractions. For example, 1 over 2, how many do we have? And then 1 over 3, how many? 3. But added together, they actually represent the same amount. Let's look at the next one, 1 over 4. But if you look at the bars, it's the same distance. They're different fractions for the same amount. equivalent. A fraction is a number that represents part of a whole. Now, how many parts to this circle here? 4. How many parts in orange? So our fraction is 1 over 4. Or we can say 1/4. Yes. You see, this fraction represents 1 over 4, or 1/4. But how about this fraction? How many parts to the circle? 8. How many parts in green? 2. This fraction represents 2 over 8, or 2/8. Let's have a look at another one with a larger amount. How about this circle? How many parts to the circle? 16. How many parts in green? 4. This fraction represents 4 over 16, or 4/16. Yes. Well, look at them again closely, and you'll notice, actually, they all represent the same amount. Yes. 1 over 4, 2 over 8, 4 over 16. They all represent 1/4 of the circle. So we can say all of these fractions represent the same amount, 1/4 of the circle. In the previous lesson, we learned about equivalent fractions that were half the circle. But equivalent fractions don't need to be half. As you can see, we can have quarters as equivalent too. 1 over 4, 1 is 1/4 of 4. 2 over 8, 2 is 1/4 of 8. And then the last one we looked at, 4 over 16. 4 is 1/4 of 16. Yes. Same amount, equivalent fractions. Even though we refer to them differently based on the number of parts, 1 over 4, 2 over 8, 4 over 16, they're all the same amount. And that's what we mean by equivalent fractions. Any questions, guys? That was excellent. Well done. Welcome back to class. We hope your students enjoyed the PowerPoint presentation about further equivalent fractions. In the previous lesson, we concentrated on how each fraction is the equivalent of half. But today, we're looking at quarters, just to demonstrate how equivalent fractions can be different amounts too. And we've got a flashcards exercise coming up shortly. But first of all, guys, time for our stretch sequence. So let's stand up and push in our chairs. And for this sequence, we'll have a game of teacher says. So listen carefully. If teacher says, we can do. If teacher doesn't say, don't do. So teacher says, hands on head. Hands on shoulders. Teacher says, hands on shoulders. Teacher says, arms in the air. Arms down. Teacher says, arms down. Teacher says, touch your knees. Teacher says, stand up straight. Teacher says, stand on one leg. Teacher says arms in the air. Teacher says touch your hands together. Teacher says hop. Teacher says stop. Teacher says stand. Arms down. Teacher says arms down. The teacher says turn around. And then teacher says back the other way. The teacher says back the other way. And back the other way. Teacher says into a ball. 5. Teacher says you don't have to hold your hands anymore. 4, 3, 2, 1, jump. Teacher says jump. Excellent, guys. And teacher says please sit down. So now teacher says it's time for our flashcards exercise for our students to demonstrate their understanding of equivalent fractions. So what you need to do, teachers, is print off the flash sheets and then cut the fractions into individual papers, fold them and place them into a bowl. And what we can do is we can have our students come forward and demonstrate how to draw the equivalent fractions. So first of all, we need our bowl. And now we need some students. So let's see who can come first. I would like to invite Pak Bung. Come and join me at the front of class. And stand this side for me, please. And choose your flashcard. And show it to your friends. 8/9. Upside down. 6/8. Yes. Okay. So 6/8. So first of all, how many parts to our circle, guys? 8. 1, 2, 4, 6, 8. Okay. Now how many parts need to be in blue? 6. 2, 3, 4, 5, 6. So here we have 6 parts over 8. Okay, now what I want Pak Bung to demonstrate is how to do the same amount but with not 8 this time, with 4. So Pak Bung, take it away. So have a look, guys. Here we have a circle, 6/8. But if our fraction has the denominator 4, how many parts need to be in blue? 3. Perfect. Take it away. 1, 2, 3. And don't forget our numerator. You see? Here we have 6/8. And here we have 3/4. But are the amounts different? No, they're the same. You can see the same portions of the circle have been coloured in blue. So altogether, guys, 6/8, 3/4, equivalent fractions. Pak Bung, that was excellent. High five. Big round of applause for Pak Bung, please, guys. So teachers, you can see the activity that we're doing in our classroom now. You can pause the video and do the same activity with your own students. And remember to choose a different student for each flashcard and have the class practice speaking together. We're going to do some more now, but I need to clean the board. Okay, and for our next flash, I think I will invite Prel. Come and join me at the front of class. And now it's Prel's turn to choose her flashcard and show it to her friends.
4/16.
Wow, okay, 4/16. So I'll do the first fraction. How many parts, guys? 16. So let's see. 2, 4, 6, 8, 10, 12, 14, 16 parts. Now, how many parts do I need to put into blue? 4. Okay, so 16 parts in total, denominator. And then 4 in blue, our numerator. 4 over 16. But now, I would like Prel to demonstrate the same amount in an equivalent fraction. So how about if we have, this time our fraction has 8 parts. So Prel, take it away. So now we need to do 8 parts to our fraction. 2, 4, 6, 8. Perfect. So now let's have a look at this fraction. In Prel's fraction, how many parts need to be in blue if we're going to have the equivalent amount? Let's think about it. How many times does 4 go into 16? 4 will go into 16 how many times? 4. Okay. So how many times? We need to find the number. What number will go into 8 4 times? 2. So how many parts? 2 parts. Excellent, Prel. Because we're looking at quarters, we've got 4 over 16 and 2 over 8. Equivalent fractions displaying the same amount. Prel, that was excellent. High five and a big round of applause for Prel, please, guys. Okay, time for our next flashcard. This time, I would like to invite Net. Come and join me at the front of class, please, Net. And Net can choose his flashcard. Okay. And show it to your friends, Net.
3 over 4.
3 over 4 or 3/4. Okay. There's our circle. How many parts, guys? 4. How many parts need to go in blue? 3. 2, 3. We've got 3 over 4. Okay, but now I want Net to demonstrate the equivalent fraction. Let's see, how many parts can we have this time? I know. We can't have 2. 2 would be too small. We need 3. 2, 4, 6, 8, 10, 12. Okay, so we've got a denominator of 12. Net will now demonstrate how to do the equivalent fraction of this denominator. So we're here, we've got 4/4. But we've got 3 in blue. So who can work out?
6.
Keep going.
7.
Keep going.
8.
Keep going.
9.
9. 9 parts need to be in blue because 9 is 3/4 of 12. So Net 9 parts in blue.
1,
2, 3, 4, 5, 6, 7, 8, 9. Perfect. You can see that even though the different shades, they represent the same amount. 3 over 4.
3 over 4.
And then 9.
9 over 12.
You can write your 9 in there, Net.
9 over 12.
Yes. 9 over 12 Equivalent fractions,
equivalent fractions,
same amount.
same amount.
Net, that was brilliant. High five. Big round of applause for Net, please, guys. And what we'll do is one more. But first of all, I need to clean the board. And this time, I would like to invite Dan to come and join me at the front of class. It's now Dan's turn to show how to do an equivalent fraction. So there you go, Dan. What do we have? 1 over 4 or 1/4. Okay, this first one is quite easy. How many parts do we have, guys? 4. And then we want 1 part in blue. So 1 over 4 equals 1/4. Now I would like Dan to demonstrate the equivalent fraction, but this time not with 4. 2, 4, 6, 8. This time with 8. So Dan, take it away. 1 over 4, what's the equivalent when the denominator is 8? What do we think, guys? No. Okay, let's have a look at this one. How many times does 1 go into 4? 4 times. So what number goes into 8 4 times? So how many parts do we need in blue? We need 2 blue parts. Perfect. You see, by using division or multiplication, we can work out 1 times 4 equals 4. 2 times 4 equals 8. So we know we're getting the same amounts. 1 over 4, 2 over 8, equivalent fractions, same amount. Dan, that was brilliant. High five, big round of applause for Dan, guys. A big round of applause for everyone doing a great job. And now it's time for our worksheet activity. So teachers, make sure every student in the classroom gets their own worksheet. And what we're asking them to do in today's lesson is to work their equivalent fractions out based on quarters. It's not always 1/4, but it's always a combination of quarters. But what's the first thing to do, guys? Names on top. And give our students around 15 minutes to complete this worksheet and just help them with anything they need. So once again, remember, we don't want the same fraction in the drawing. We want an equivalent fraction of the same amount. So Lakdal, this one's for you. And one for you.
Thank you, teacher.
You're welcome. Prel, here's yours.
Thank you, teacher.
You're welcome.
Thank you,
Dan,
teacher.
for you. You're welcome. Chu,
Thank you.
you're welcome. Nadia, you're welcome. Pat, for you. You're welcome. You're welcome, Pak Boom and Net. So names on top first, guys, and then have a look at each fraction that's given, and then see if you can do an equivalent fraction that isn't the same. And we'll do the first one together. So the first one is how many quarters? 3 over 4. So we've got 4 parts, and 3 are in blue. 3 over 4. So an equivalent fraction could be, we could double this number. What's 2 times 4? Equals 8. So let's do 8 parts. Okay, so now we've got 8 parts. What's 2 times 3? Equals 6. So we could do 6 over 8. 1, 2, 3, 4, 5, 6. These two are equivalent fractions. 3 over 4 is the same amount as 6 over 8. Or we could do 2, 4, 6, 8, 10, 12. And this time we would use 9. Because 3 times 4 is 12. And 3 times 3 is 9. Okay, so 12 over 16. If we have 4 quarters, how many parts will need to be in blue? What do we think? How many quarters of 16 is 12? Let's do it together. Almost. So 12 over 16 is the second one, yes? 2, 4, 6, 8, 10, 12, 14, 16. And how many parts in blue?
12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 over 16. Now how about if we put it into 4? How many parts do we think? Not 1. 1. 3. You can see it's the same fraction. How many times does 4 go into 16? 4. How many times does 3 go into 12? 4. Equivalent. 4 times 4 is 16. 4 times 3 is 12. Same amount, equivalent fractions. Welcome back to class. We hope your students enjoyed the worksheet exercise where they had to read each of the fractions in the questions and then draw and shade an equivalent fraction that shows the same amount but in a different fraction. And that's what we mean by equivalent fractions, guys. Same amounts represented with different numbers. And that's all we've got time for today. So we hope you've enjoyed the lesson and now understand more about equivalent fractions based on halves and quarters. And we'll see you again soon in the next lesson. So can we turn to wave and say goodbye, guys? Goodbye. Bye-bye. See you again soon.